Hello everyone, I am Alessandro from Arduino. I'm here to talk about some news about the open source tools from Arduino that are relevant for the ESP community. I will talk about four things. I will talk about the new IDE, the command line tools, the actions for continuous integration, and the library ecosystem. Let's start with the IDE. I'm sure most of you are familiar with the Arduino IDE. It's a very known piece of software. It's been around for 15 years, and it's known as the de facto standard for Arduino boards and non-Arduino boards, as it supports more than 250 boards, including, of course, ESP8266 and ESP32. Just to give you some numbers, it was downloaded over 39 million of times just during last year. And it's localized in 66 languages. And also we counted that it is mentioned in at least 3,000 books. So it's a very popular piece of software, and I'm sure most of you, many of you actually, use it for your development projects. Of course, the architecture of the IDE is modular. So for each family of boards, there is a core, which is a pluggable component that defines the characteristics of each board. In case of ESP32, the core is maintained by the Espressif team. It's super well documented, super feature complete, very cleanly written. So that's what you are using with the Arduino IDE to program the ESP32 boards. Some features of the IDE include the library manager, include a serial monitor where you can send and receive strings back and forth from the board, a serial plotter, and some other features, including code examples that comes with the library and the ability to customize menus and options for each board. So we decided to revamp this IDE based on some feedback we got over the years from users. One is about the limited editing capabilities compared to modern editors. We are now used to a very modern editor, so with many features, with a good user experience. So the old IDE written in Java started to be a bit limited for many users. And also we got the request for a built-in debugger. So also there were some technological issues. The fact that the IDE is written in Java started to be a bit of a problem, considering that modern operating systems are not supporting Java, are starting to dismiss their support for Java. Also, the licensing from Oracle is not friendly with app stores, and the monolithic code base and the complexity of this Java code base has been limiting the contributions from the community. So we also kept in mind that there are some alternatives. So expert users are using other solutions like Platform.io, like the Microsoft VS Code extension, or the Visual Micro plugin for Visual Studio, or completely different IDEs for embedded development. So we decided to start a redesign process with some principles in mind. First off, we wanted a modern editing engine with a better user experience. We want to maximize accessibility of the IDE. We wanted to create a framework, an architecture that would allow for faster development of new features. And also we wanted to break the monolithic code base. So we split the IDE in a front end and a back end. The back end is what does the compilation, the upload, all the core logic is now in a command line tool, which is called by this front end. And also we wanted an IDE that could potentially in the future support also Python, JavaScript, TinyGo, other languages. And we wanted to facilitate community contributions. Also, we wanted an IDE that could potentially be integrated with cloud solutions for sketch backup, sharing, and other things. So we, after a very long process, after 19 beta releases, after lots of feedback from the community, this September, so a couple of weeks ago, we released the 2.0 stable version, which was already downloaded by 1.2 million people just in 15 days. As you see, the interface is very, very similar to the previous IDE, but with some modern features. Let's see them. One is the auto-completion. So while you type, you get the list of methods that you can call on a given object with their signature, with their arguments. This is a modern thing that all editors have, and now also the Arduino IDE has. Also, when you right-click on a function or a method call, you have the ability to jump to the place where it is defined. So if you are unsure about what a method does and it's not clearly written in its documentation, you can right-click and go to the source file of the library where that method is defined, so you understand exactly what you are calling and what it will do. Then the IDE has a very requested feature, which is a dark mode to relax your eyes. And then we revamped completely the serial plotter. I'm not sure how many of you are familiar with this feature. It's basically a simple way to plot visually data coming from the board. Let's see a video. So the new serial plotter was designed with the ability of supporting high quantities of data. So you see here, this is real-time chart. This data is coming written on the serial port, one data point per line, and you can also plot multiple series, and from the interface, users can, as you see, check all the numbers. They can enable and disable data series, and they can export the data. Another feature is the in-app update. So when there is a new version, you can just click on download and it will be automatically updated without you having to go to the website. Another important feature is the built-in debugger. The Arduino IDE finally gets the built-in ability to debug your sketches. They run on hardware, so they are not being emulated on your computer. They will run on the actual board, but from the IDE, you are able to pause their execution and inspect their variables. Let's see how it works. You basically work normally in the IDE, then you click the debugger button, and this panel opens. Then you set the breakpoints close to the lines where you want to stop execution. And as you see, you can inspect the contents of the variables. And you can even change the contents of the variables while the sketch is being executed. It's important to say also that this feature for now is experimental and is only supported for the Cortex boards. However, the architecture of the IDE is modular, so it's basically a matter of configuring some information in order to link the IDE to the components providing debugging for other platforms. We just need to document a bit better this framework. So as of now, there is no built-in support for ESP32 debugging, but the IDE is almost ready in terms of architecture. So if you are interested in bringing this feature to ESP32 quickly, do not hesitate to join us, because the IDE is an open source project. So you are totally welcome to join us on GitHub, start the discussion, and we will for sure appreciate your contribution in accelerating the implementation of the debugging for ESP32 platform. Let's see the architecture of the IDE. As you see, it's based on the open source framework Thea, which is based on the same architecture as Visual Studio Code. So it's everything is written in TypeScript and is based on the Electron framework. And it's downloadable, try it now, on arduino.cc/an/software. Now, I'd like to talk about another important tool that we released in the past couple years. It's the CLI. It's the command line tool. So as I told you, when we developed the new IDE, we decided to move all the core logic to the backend, to a command line tool, so that people can use the command line tool directly, even if they don't want to use the IDE. What can it do? It's a very flexible tool which allows you to compile your sketch, to upload it to a board, install libraries, and monitor the serial console. How does it work? You can install it very easily. If you are on Mac, on Linux, you can just use Homebrew to get it, or you can just go to the website, to GitHub, and download the binaries and install them yourself. Then, in order to configure it for ESP32 boards, you just type this line of code where you set the URL of the package index for ESP32 board packages, and then you just install the ESP32 core That's it, and you're ready to go. So you plug a board in your USB port and you type board list. You get the list of all the boards available locally on your workstation. As you see, there is the port, the serial port, and there is also the board name if it gets recognized. On the right side, you see the fully qualified board name, FQBN. It's basically a string that identifies the board. In this case, it's an Arduino board based on the SAMD architecture, and the board identifier is Maker Wi-Fi 1010. That FQBN is important because you use it when you issue the compilation command. Let's see how it is. Basically, you are in the directory of your sketch, you want to compile it, and you type compile, giving the identifier of the board type. In this case, it's a NodeMCU board, and it will be compiled as you see directly without any additional information you have to give. As a second command, you can upload the compiled sketch to your board, so you just supply the serial port name and it will be done for you. As you see, this is very convenient because you can script it, you can integrate it in your custom workflow, and also you can use your own IDE. Suppose you want to use Sublime Text or you want to use something else, you can just use Arduino CLI from your shell and be free, basically. So another feature is the serial monitor. So with this command, you can just attach your terminal to the serial port to your board and have an interactive way of receiving and sending data from and to your board. Also, there is an advanced feature that not many people know that we released last year, and it's called build profiles. It's a way to freeze and store the exact versions of the board package and the libraries you are using. So when you compile, when you issue the compile command, you just add the dump profile argument, and on the terminal, after the compilation, you will get this little chunk of YAML, which describes exactly the environment of this compilation. What do you do with this chunk of text? You can copy it inside a file called sketch.yaml, which you can later reuse to recompile using exactly the same versions. So in this case, when you compile, you just call the name of the profile inside this file, and it will automatically get the library versions you originally used, the board package version, and you are sure that your compilation is the same as the previous one. We call it reproducible build. As you see, the YAML file can contain multiple profiles, so you can store many combinations of settings and choose the one you want to use each time. Let's now talk about a more advanced set of tools that we released. I'm sure that most of you are familiar with GitHub and use it to store your projects. As you know, on GitHub, there is the ability to run automated tests after each commit. Suppose you work on a feature, you commit it to your GitHub repository, you want it checked. We released some GitHub Actions which allow you to run compilation of your sketch after each commit automatically on all the platforms you want to support. This is an example of what you would see after each commit, after each pull request on your repository. It basically tries to compile your library or your sketch on one or more platforms and report success or failure, so that you know that, at least in terms of compilation, your code is correct. Of course, compilation does not guarantee that it will actually work correctly on hardware. But for sure, if it cannot compile, it will not work on hardware in any case. So this is a way to accelerate your development and make sure you don't introduce regressions. How does it work? You just configure a very simple YAML file inside your repository. There are some examples in the repository. This is not the simplest one. This already contains a number of features. As you see, you you select the sketches in case your repository contains multiple sketches. You list the libraries, and you specify the board identifier where you want the compilation to happen. That's it. You can also do the same for libraries. So if you are hosting your own library on GitHub, you can just configure all the boards you want to support, and a matrix of tests will be performed after each commit. There is also one more GitHub action we released, which is able to compile reports. So after you run, after the automatic compilation is run, you will get also some information related to the changes in resources used by the sketch. This is displayed, if you want, also as a comment, as an automatic comment in your pull requests, showing whether your change is introducing, for instance, an optimization or increased consumption in terms of memory, for instance, or in terms of sketch size. So you can keep track of the impact of your changes. And this is very important because you see it as a matrix on all the platforms you want to support. These actions are completely open source. You can find them on the Arduino GitHub, so get them now in order to increase the quality of your code. Last but not least, I would like to talk about the library ecosystem. I'm sure most of you are familiar with libraries because they are the building blocks that accelerate your development. As of now, these are the numbers. The Arduino Library Index contains 5,200 libraries, which is a huge number. Also considering that just during this year, during the past 9 months, we got 700 more libraries registered in the index. So the community is growing even faster than in the past. We counted that 76% of those libraries declare explicit compatibility with ESP32. Which is a huge number, which means that there is plenty of choice of libraries doing whatever you want, from displays to network to radio to communication protocols. Everything is more likely to be found in the Arduino Library Index. One important thing that we did, and that probably is behind this growth of libraries, is that we dismissed our manual approval process in favor of an automated submission process. Now you just have to go to a GitHub repository called Arduino/library registry, and you submit your library just by editing a file. So you submit a pull request with the URL of your repository. That's everything you need to submit, no additional information. Then a bot will automatically check your library, will automatically check if it's correctly formatted, will give you warnings, will help you troubleshoot the mistakes. And if everything is fine, it will automatically, instantly approve your library, which will be added in the Arduino Library Manager and available for all users inside the IDE and listed in the Arduino website. That's all from Arduino. I look forward to discuss with you. I want to remind that all this is open source. We want to support all the boards, all the platforms, all the technologies and the architectures, and the ESP community is so important for us. So you are more than welcome to join development because all this is a collaborative effort. So if you want to improve things, to introduce a new feature, to share an idea, just reach out to us on the GitHub repositories, which are the best place to join the development. Thank you. Thank you, everybody.
And now we are back from one more Q&A. And for this one, I would like to invite Alessandro to join us. Hi, Alessandro. How are you?
Hello, fine. Nice to meet you. Hello, everyone.
It's nice to meet you too. So we have a couple of questions here. So I will start with one from Vojta. So what's the best way to contribute to the new Arduino IDE 2.0, especially for the new debugging feature?
Yeah, there is a GitHub repository where the development happens. The Arduino team works publicly using that GitHub repository also as a way to track all the activities, because of course we want to be fully transparent in what's going on. So please join the development, find the issues in the GitHub repository in which you are interested, and join the discussion. Basically, I suggest to first join the discussion before you jump into coding. But of course, then the very appreciated step is to submit the pull request with code. When it comes to debugging, everything is fully open source, so you can already study how it is implemented for the Cortex boards, which are now supported. Basically, you will see there is a modular architecture with some metadata files which define the GDB server to be called, and so on. And then it uses an external library called Cortex Debug to communicate with the board. Of course, this will need to be replicated also for ESP32. We would like in the next months actually to document this architecture properly, to define a proper specification on how debugging can be implemented for other boards. So if you're interested, join the GitHub discussion, talk to the team, so we can sync on the specifications for this.
Okay. So next question. Would the coprocessor be able to be programmable in Arduino also? If not, what version of C could I expect to use?
So I'm not the most expert person on this topic. As far as I know, it is possible. As far as I know, there are libraries which can be imported that allow you to do this. I can tell you for sure that for other boards, like Arduino boards with multiple cores, this is possible by basically selecting the other core as if it was a different board in the board selector. So in the boards, you will find two boards, which are basically the two cores of the board. I don't know if this is implemented this way, but if it's not, it's technically possible also this way.
Okay, great. So next question. It is possible to better organize the board selection by adding submenu within the IDE 2.0, like example like ESP submenu S2, S3, C3.
Very, very good point, especially for a crowded course like the ESP32 one. I would suggest, Rodrigo, if you could join GitHub and post this idea in the issue tracker so that the team can have a look at it.
Great. Next question.
Especially because I love this thing and the new IDE. Sorry. I just want to add a part of the. There is not just the menu to select the board. There is an entire dialogue which is much more user-friendly. So it allows also to create a more sophisticated or more clear navigation among boards. So definitely yes.
I see. So will the new IDE 2.0 also use library caching like Platform.io?
Good point. So the IDE 2.0 uses the Arduino CLI as the backend for compilation. The Arduino CLI now implements some caching to a certain extent, but more can be implemented. That's in the appending task in the issue tracker. So if you want to help us, please join development and we can make this happen.
Good. Next. Live Q&A. How to use external plugin tools in the new IDE 2.0? Is there a JSON port or anything else?
This is a very important topic. I saw also other questions asking for the stack decoder extension of the Arduino IDE. Yes, the plan is definitely to document how to create extensions for the IDE. This IDE is based on Thea, which is basically based on the specifications of Visual Studio Code. So the architecture of these extensions of Visual Studio Code is the same used by the Arduino IDE. So it's a matter of writing HTML and some TypeScript. So it's even a much easier process than developing in Java, like the old IDE required. So yes, we are going to release very, very soon the instructions and the specification on how to create these extensions so that everyone can develop third-party extensions like the one mentioned before.
Okay, great. So the last question, would there be an effort to allow or simplify implementing external plugin/tool in the new IDE? ESP Arduino has some tools for the that need to be ported, like the ESP exception decoder.
Yeah, this is the previous answer applies to this question as well. As soon as we document how to write these extensions, it will be extremely easy to create extensions for any kind of job. Extensions will be able to read data coming from the boards, so you can use it to display live data and other things.
Okay, so I think we have an additional question here. So I use many different boards. Is there a way to associate an .ino file with a board?
Sure, it is. This is possible now thanks to a feature that I mentioned during the talk, but I understand I spoke very, very fast and mentioned so many things. This thing is called build profiles, and it's available only on the command line for now, but it will be soon exposed also in the IDE. But if you want to experiment with this on the command line tool, then just Google for Arduino CLI build profiles. You will find the instructions. Basically, when you do a compilation, you add the dump profile argument, and the board identifier will be dumped to a file that you can store in the sketch, and you can later reuse when you recompile that sketch, as it will automatically select the same board you used the first time.
I see. Okay, so I'd like to thank you for the talk, for being here with us today, for the Q&A session. So thank you so much, Alessandro.
Thank you very much. Thank you, everyone.
Thank you. Bye.